Thank you for the introduction, but I'm going to introduce myself again to be able to introduce you my domain and my company and myself. I'm Ceren, Şahin, Gebizli. I'm actually a PhD in computer engineering, and I'm also working as a test architect at Vestel Electronics at R&D Center in a design verification and test group. I'm responsible of the functional tests of televisions. And before switching to my talk, let me give you some brief information about our domain and Vestel. Vestel is actually ODM and OEM, consumer electronics and home appliances manufacturer. Vestel brand name is only known in Turkey, but we have also more than 100, 200 customers all around the world, which are manufactured by Vestel, like Toshiba, Panasonic, Loewe, GVC. Maybe you're familiar with these brands. We are producing televisions for them. So we have many challenges, as you know, and there are two presenters. They were so good about telling the embedded systems like automotive and space. Now I am in the embedded systems, but you're more familiar because you're using everyday television. So let's see the challenges. In R&D Center, we are actually a lot of people, a lot of engineers, like 800 engineers in R&D Center. There are hardware engineers, system design engineers who are dealing with the design of the main boards and the power boards according to the cabin or the panel of the televisions. And there are software engineers that are dealing with the source code of the televisions. We had very large code base, such as like 5 million lines of code. And we are test engineers. We have test engineers like me. And we are like 50 test engineers and 60 test technicians as well in our test group. And we are dealing with the testing processes of 10 ongoing projects. Every month we have 10 projects, different projects, and we are dealing with the functional tests and performance tests and automation and the certification test as well. We are not only doing functional tests because we are selling our televisions to different countries, so every different countries has their own specifications, their own broadcast system, so we need to verify all these systems in their places, in their countries, as well as in the laboratory. And since we have some private customers like Toshiba or Panasonic, they have their own specifications as well. So there are really many configurations about the TVs. We are not producing the TVs just one design, but we are configuring all the features according to the customer or according to the country. So and time to market is very short because there are many competitors in the market like Samsung and LG and the others. So there are many projects. So we have to be really on time and so sharp about test planning and verifying all the bugs before the production, because there are also some test engineers who are giving the approvals to software versions before the mass production. We are sending some software version to the production line, and they are putting the software into the televisions, and they are starting production like millions of televisions. So whenever there is a bug on a television just before the approval, so we have to stop everything. So everything is actually stopping, like shipping and the production, shipping as well, and everything. So the program managers are always dealing with the some delays of the project. So we need to be very sharp on test planning. And we have limited resources, as I said, like we are 50 engineers, and we are always dealing with the different projects, so time is really important for us. And I said that we have many challenges. When I first started my job in Vestel, it was 2010, and I want to tell you that how we were testing at that time, at 7 years ago. We were really new. We didn't have any ISTQB certifications, nothing. We had some only exploratory testers. We had no test designs and no test suites, no test automation. We had only some checklists, like in an Excel files. There were some sentences by leading the tester that do this, do this, do this, but there were no expected results. There were no requirement coverage, no coverage at all, actually. And the tester was just checking the television in an exploratory way, just doing something with television like an end user and trying to find some bugs. But and at that time, at the same time, there were actually 3 engineers in the test automation group. We were trying to build a test automation group, a dedicated test automation group in the functional test group. So they were trying to build a test automation system for our televisions, and we actually had no idea about what to do. We were always searching for in the market for test automation tools, but since they are embedded systems, the television is a very specific and actually really an important product, so we couldn't use the commercial tools from the market by buying them from the market. It was not available for the televisions. So we had to create our own system by the new test automation guys, but there was another problem. The test automation people was not aware of the test oracles, and they were not able to define the test oracles, and they were not able to automate because they were not aware of what to automate, because there were not effective test design before the automation, because our automation system was not effective because of that, because we didn't have any test design technique. We were not using any test design technique. So after 2 years, I guess, yeah, it was 2012, I started to do my master science in the same company, because we had a special collaboration with the university from Istanbul, so I started to do my master, and I decided to study on test design techniques, because I really wanted to have a test design in my group, because I was really spending a lot of time to test the televisions. We were always in the company, we were always trying to find some bugs, but they were not documented, they were not good enough. So I studied on test design techniques, and I started to study on model-based testing. I just met with model-based testing in 2012, so I thought that model-based testing can really fit with our domain, because our domain is embedded systems. So a lot of embedded systems companies are using model-based testing, such as automotive or space or the aircraft. So I thought that, yes, why we don't use this model-based testing in our test group as well. So I started to search about it, and we got some tools and some demonstration tools, and we tried to use model-based testing. So, and we saw that, yes, it's working. So why it's working? Because model-based testing helped us to automatically generate our test cases based on the systems that desired behavior of the system under test. So we could easily generate our test cases from the model-based testing. So we started to use model-based testing. We designed our tests by model-based testing. We had many test models, and our automation usage is increased, and our ROIs are increased, and we could easily manage the requirements from the models, because whenever you design a model, you can easily see that there are some states and transitions, and you can easily manage the requirements, because you can easily assign the requirements to the transitions. I will show you in an example. And after designing some models, and we wanted to focus on more effective test design, and we thought that why we are not using this to be able to find some faults that are reported from the field. Okay, we could find some functional problems from the televisions by using the test models and test automation, but we were still lack of the the bugs reported from the field. So we wanted to focus on the test design that can find the mostly reported faults, or the mostly error prone. So we started to use in a different way. And before I introduce you our approach, how we use that torture test, I want to show you an example of system models used for model-based testing. This is a sample view of the model, the test model that we are using in our test group. And we are using Matelo model-based testing tool, by the way. As you can see, there are some states, and there are some transitions connecting between the states, and there are some probability informations on the transitions. We are using finite state automata, as you see, and we are also using Markov chains by means of putting some probability values on the transitions as well. So how we are using this, how we are using the probability values, actually, when you design a test model like this, as you can see that the probability values are equal to each other. I mean, if there is one transition between one state to other state, the transition probability is 1. But if there are 2 transitions that are coming out from one state to 2 states, the probability just is divided by 2, like 2.0 and 0.5 and 0.5. So after putting some probability values, we could generate our test cases based on the probability values. So by using this, we design a longevity torture test. What does that mean? Let me tell you this, like when you buy a product, you are informed that that product's lifetime is like 10 years, because this information is given you by analyzing the materials or components or hardware of the system. But what about if we analyze the source code, the software of the system, and give you a lifetime information until a major bug occurs? So we thought about this, and we designed a longevity torture tests. For this, we took some usage data from the real users, from the real field users, about like how much, what kind of features they are using mostly with their televisions. We analyzed this, and then we designed a torture test. How we analyzed this? Actually, we are doing this thing a lot. We are giving some projects, some engineering samples, some prototypes to our workers, to engineers in the company. So in this study, we did the same thing. We gave 30 television to 30 field user for 30 days. After that, after 30 days, we collected the log files from them, and the log files are like execution traces of all users. So after that, we analyzed the execution traces, and we saw that what kind of users use what kind of modules in their televisions, which features they used mostly. So after analyzing this, we did this table. You can see the modules that are mostly visited by the users after we analyzed. And after analyzing the total number of visits of the users with their features, we calculated some probability values based on the visited modules. It's so basic, actually. You can just sum up the total number of visits, and then you can easily see that these are actually mapping to each other, the probability values. And as you may see, the connectivity features are mostly used feature in our televisions, because nowadays TV platforms are in a fast transformation from their old electromechanical systems to complex software systems. And we have if we think about a full feature TV, we have 200 features in our TVs, and including the connectivity items. We are not only using the broadcast of our TVs anymore. We are using the outputs. We are connecting some game consoles like Sony PlayStation, Xbox, or something, the other devices, the HDMI devices or Blu-ray devices. And we are also using, for example, Netflix. We are watching Netflix from our televisions, and we are watching 4K videos from YouTube. So we have many actually items, features in our televisions. So that's why we wanted to use this. And yeah, after seeing these probability values based on the features, I'm going to show you the model. This model seems like a bit abstract because actually in each state, you can see there's some white things on the states. It means that there are also sub-models under those states. There are other features under those states. And based on the probability values, we assign those probability values to each transition. And after that, we could easily generate test cases based on these probability values. And I want to tell about something more about test automation, because maybe you think that we are just putting this and we are getting some test cases from the models. Yes, we can get some manual test cases in order to be able to see and check the televisions by some from the model-based testing tool. But what we are doing in parallel, we are embedding some test codes into the transitions as well in the model. So what does that mean? That means that we are also getting test scripts automatically during the test generation with this model-based testing tool. And TVs are really complicated systems, so test automation is really different in our system. So I wanted to show you the environment a little bit, because and then for 3 days I'm listening, the other guys are talking about some cool test automation tools like Selenium. I really wanted to use. I know those tools, but I cannot use those tools with this environment because the televisions are really different. You have to put some signals. You have to have your own test automation set up. You have to behave like that there's everything is set up for the television, like an end user, if you want to do a test automation. In our test automation group, we have some test automation rooms. There are actually 5 test automation rooms. 3 of them are torture test rooms. What does that mean? We are putting the televisions together in torture test rooms. For example, 5 TVs for each project, and we are torturing them. We are trying to kill them. We are trying to kill their software by some specific test cases. And we are designing those torture tests with model-based testing, and this is actually the longevity one is one of them. And I can show you the framework of our test automation system. We built it, and there are some requirement management model, test suites, model test cases, executor, and reporting. We are getting everything from here, and we can follow everything from this framework. And yes, this is the executor part. By the way, we are using Python test scripts in our test automation system. Actually, the software of the television, the source code is in C++. It's actually the Linux-based, and but we are only doing model black box testing, and we are doing test automation by the way, just comparing the captures. We have some reference pictures from before, and we are putting televisions on the test automation system, and we are opening the backside of the televisions, and we are connecting some LVDS cable to the panel, and we are getting captures from the panel itself, not from the webcam, because it's not good enough getting captures with webcam. It's so different. So we are getting the captures with the LVDS cable, and we are comparing the captures by using some algorithms like PSNR or OCR. And I wanted to show you the result. Actually, we did this longevity torture test designing study with the traditional methods. And there was some engineer who created the test cases, and then after that he automated the test cases, and there were like 300 test cases, and it took 15 hours to execute those test cases, and we could only find 4 faults, and our faults like more usages of the TVs, like there was no audio, for example, from Netflix, and we could analyze if this problem is because of this ours or the Netflix side. We analyze some signals, PIDs, from the audio videos, and we can see that yes, this problem is causing from our source code. And then and I switched to model-based testing side. Yes, we did this study with model-based testing, and we design our model, and we embed the test scripts, and then we could get 79 test cases, and each test case executed like 1.5 hours, and we could easily detect more critical faults like crashing problem, or the TV opening, resets and opening itself, and remote controller buttons are not detected, or buffering problem with the remote controller buttons. There were really additional critical faults while we did this study with model-based testing. And with longevity testing, we could simulate 1 year usage in 23 hours. What does that mean? One test case actually simulates the 1 day, and in 1 day we could simulate the 16 days, and in 1 year, if you product 16 and 23, it's like 300 or 60 something. So we could simulate 1 year usage of one user in 23 days. So of course there are some future works about designing the torture test. We have also different torture tests, like we are analyzing the memory usages of televisions, and we are giving some probability values based on the memory usage. So this is the other work maybe I tell about later, and maybe the coffee breaks or the lunch breaks. So, and the conclusion, I told you some story about the consumer electronics domain, some televisions, and the context is the industrial context and televisions, and actually usage profile gave us an idea about the mostly used features, and we could focus on the possible paths by using the probability values from the usages. And actually we used all these test cases as a regression test as well, so which was really good for us. So yeah, I finished it. Thank you very much for listening to me. If you have any question, I can get it. No, you seem, by the way, so nice from here.
Thank you very much, Ceren. I think the audience loved your presentation. I did, at least. We have many questions. We have many questions. So let's see the very first one. If you could test only 3 things, what would be those? 3. If you could test only 3 things on a smart TV, what would be those 3 things?
Okay, you wonder about the critical bugs of home features, and I could first detect I will first test the CI modules of televisions, because you guys all maybe have set-top boxes. You are putting some cards to descramble the channels. Maybe you are using it, and we are actually giving some modules in the main boards, and we are putting those cards to televisions directly. So first I will test it, because it's hardware-related test. So if there is something wrong with hardware, we cannot do it. We can the rework costs are really great, expensive. So we could first test the hardware-related issues. So that's why I first test the CI modules of televisions, and other actually the panel-specific or hardware-specific tests I could do that. But if you are asking the software, I could test the connectivity side, like Netflix or YouTube, because nowadays everyone is using the connectivity features, televisions, mostly more than broadcasting. So I will do that.
Thank you. The next one. What is the most remembered bug you have found?
Okay. A lot of. Okay, our testers are always writing so stupid bugs as well, but I don't know. Because they're also doing exploratory testing after all this model-based testing thing. And once, I remember one of my testers said that I opened YouTube and I watched some 4K videos. After that, I close it and I just record an event from the channel, from the broadcast. And after that, I close it and then I open media browser. Now it's gone. I said that you did many things. What's the point on this? And I didn't understand anything. And he said he took some log files, and the software engineers actually analyzed it, and it was actually caused by the media dialog of the YouTube application. So it was really interesting because he did a lot of things, and at the end, it just came from the beginning, the YouTube itself. So yeah, it's interesting.
Thank you. We could hear from in the previous presentation that hacking car system is possible. Yeah. What about TV sets? Do you also test for safety?
No, it's so new. Yes, we will have some security testing on TVs as well, but not yet. No, it's not open. So.
Thank you. Data leak threats and examples discussed recently on such smart devices. Do you also cover such risks? Data threats?
Data threats. Yes, it can be from the connectivity part, but yes, as I said, we are not dealing with the security parts yet, and I don't know. I don't know. By the way, I'm changing my job, so I will be in security sector soon, so I will learn.
Thank you. Szilárd asked about the benefits of MBT model-based testing. I think we had a slide, but if you just, in case you want to add something.
I want to add, yes, it provides maintenance about your test cases, because whenever there is a change in your requirements, you can easily manage it from your model, because whenever you see that that transition should not be exist anymore, so you can just remove it by seeing this. So I can say this one as a maintenance factor. Yeah. Additionally, this one.
Thank you. David asks about if a customer reports a fault, you can get logs from the actual Smart TV set of the customer, or you need to reproduce the fault without that? Say a customer reports a fault.
Yes, they are doing this many times. Our customers actually are not directly reporting to us. Our customers like Toshiba or Philips or the others, so they are just writing those problems into the Jira directly. And they are actually so good on this because they are writing the bugs step by step, and we can easily reproduce it. But if we have to take some streams, this means that if that bug is related with the field, I mean the broadcast of the other countries, because every country have their different satellite system, for example. For example, in United Kingdom, they are not using DVB cable, they are just using DVB terrestrial, but in Germany, they are using only DVB cable, so it's so different. But sometimes we have to go there to take some videos, some streams from them, or maybe sometimes we are having some contents from them, so to be able to reproduce the bugs, but mostly we could do it. We can do it, reproduce those bugs.
Thank you. Szilárd is asking how many test TV sets you have.
At home, 10. I am a field tester. I have 10 televisions at my home. I'm always watching. Yes, as I told this story to everyone that I'm doing testing. And I'm always watching Netflix because I have some accounts. I should do it because long time watching is really different process. After long time watching, there may occur some memory specific problems because the memories of televisions are not so big, and they after you watch some 4K videos or after you are using some connectivity related features, so the memory can be high, so that's why I'm doing this thing at home. I'm actually writing some bugs before sleeping, then I'm going sleeping, and I'm reporting after that. Yeah.
What about the test lab? How many TV sets you have in test lab? I mean, your team testing the
Our test teams actually, we are big because we are not only doing television testing, we are also mobile phones and home appliances products. We are like actually 150 people in test group, and on my table I have like 5 or 6 televisions from every inches. Once I had 84 inches televisions like this much. I tested that television, it was so good. And we have many.
Good. Do smart TVs report usage data to the manufacturer? To the manufacturer, I mean, as a customer, my TV set, does it report the data to the manufacturer, to the producer?
Yes, it is.
Yes? If yes, can you give examples what type of data is reported and how they are used?
If you mean data like...
usage data?
Like... privacy. Yes, they are entering their user passwords or usernames about bank applications, but I don't know that site that much. I don't know.
Okay. Andras is asking if you test only Android smart TVs or other
Yeah, we
as
have
well.
Android smart TVs as well, but we had only one Android TV project, and we did it, and then we done it. And because we did testing by using the Android test lab itself. And it was so confusing because there were Android, there were another application layer in our software engineer from our software engineering department, and we were also working with some other guys from Serbia and also from UK. So it was a big project, but I have never done the testing of Android TVs because it was not my project. But yes, we had once. Yes.
Thank you. And one more question. We're running out of time. So Mate is asking about bugs. If you find the bug, how do you know if it's a system problem or if the problem of that particular TV set?
For example, if you mean that system problem and the product itself,
like the software,
yeah,
software feature
I
problem.
see. Actually, we only detected with the software engineer because we are only doing black box tests. And whenever we see a problem, so we are just basically entering the Jira, and then software engineer comes to us, and sometimes he wants to reproduce with us, and then he's giving some solution, and we can see that what kind of solution he gave to us, and we could see the source code, the changed part of the source code, and they are also writing if I solved this bug from the application layer or the other, for example, graphical user interface layer or something like that. So we can see it only after it's solved.